Hey, what's going on, guys? Komagigenzi here. In this video we'll separate make, move and take back functions and also implement pound promotion. So if you're interested, without further ado, let's actually start. Okay, so let's define the make move function. So I say def make move. It takes the self instance and the move itself. Okay, and I can make use of this guys here. Okay, and so putting the piece on the target square, then erasing the source square. Then sprint the board as far as we're still in the debugging state. Okay, so put it here. Then don't forget to change the side to move. So self.side x or equals 1. So if the side is 1, it would be 0. If the side is 0, it would be 1. So just XORing, the simple XORing here. That's why it's so handy to use 0 and 1s for sides, for simple swaps. Okay, and then the take back one. Well, actually before that we need to, okay, I changed the variables later, so let's provide, so take back, let's provide the skeleton first. So self move, and here restore the captured piece on the target square and restore the source piece, the original piece on the source square. Okay, copy the debugging information, paste, and self side x or equals 1. I'm sorry. Okay, this is pretty it. And yeah, now let's go for, so we need to take all the source square, target square, all the stuff from the move. So this would be move target. So I'm using these values. Okay, so move target, and here we have move piece. Okay, and here again, like move target, and here move captured, move captured, and here move source and move piece. Okay, I think this is it. Great. So yeah, now instead of printing the moves, we can just say chess.make move and pass the move as an argument, and also chess.take back, and hopefully to say exactly the same output we had during debugging the move generator. Okay, square is not defined. Okay, just forgot to change this one. So square move source, I guess. Is this called source? Yeah, source. Great. Sorry, it's just something happening to my voice. Okay, let's try again. Okay, so now we have our move generation being completely separated from the generate moves function. This is great. And now let's test with a bit more sophisticated FEN. So one of the benefits we have by using this source code and data separation is that we can, and also the fact that we do rely on the FEN string as the basis for the further chessboard kind of like initialization. So we can just paste the new FEN in, and without any parse FEN methods as we've been implementing in the past, we just can go straight ahead. So if I did everything properly, it now should initialize completely new FEN, and this is it. Okay, and let's just see how it works. So capturing opponent's pieces, not capturing own pieces. Okay, this is great. It's not going to be castling because this is the very proof of concept toy implementation. So castling moves are not on the cards, but all the rest moves are on the cards. Okay, it seems to be nice. And now here is the problem, guys. So just to give you an idea. So let's consider right over in here, say, let's put a white pawn. And now it's the matter of pawn promotions. Okay, so let's run. So you see, like, the pawn is not promoting. Okay, so this pawn, so I'll just show you this one more time. So look here. So we have the pawn on the 8th rank, but it's not promoted to queen. Okay, so that's a bit of an issue. Let's fix this. So the most simple way of doing this is the following. So we can simply say if move piece is equal exactly to white pawn and move source in relies within the, so for white pawns it should be promoted only in the 7th if the source square is within the 7th rank, so rank 7. So if pawn stands on one of these squares, then it can be promoted. And move in self dot rank 7, right? For white pawn, rank 7, good. In this case, we just want to put a white queen onto the target square. So I can say self dot board and move target equals to white queen. Okay, and now the same but for black. So just copy this. Okay, so for black we want a black queen for target if it's on the rank 2 and if it's a black pawn. Okay, so now let's test this one more time. Okay, now we have this promotion here. Okay, so promotes to queen only. Well, this is a bit of a limitation, queen only promotion, but it's literally enough for the very first engine. So yeah, great. And now let's swap the side. So I just restore the FEN back here, and here let's make it like so. And now this pawn would be black. Save. So let's test. Okay, so I just need to walk through all the pieces. Okay, and yeah, queens, pawn is queening here. By the way, when we take back, it gets restored to the pawn, which is obvious. Okay, here. Yeah, so I think this is kind of it. Okay, guys, so yeah, I think this is it. And in the next video, we'll create a very simple, a very rudimentary evaluation function. I can't do search because in search we'll need to return static evaluations. So in order to do that first we need to implement the static evaluation. So yeah, this is it from my side. Thanks for watching. Until the next time, and take care.